This is problem number 1 for assessment number 5. And this problem, it says solve the inequality. And they give you an absolute value inequality. Now, I'm going to show you 2 ways to solve this absolute value inequality. The first way, so way 1, you take this absolute value inequality and you say, all right, I know that the absolute value of this has to be greater than or equal to 6 from 0. So that means that 7 minus 6x has to be greater than 6, or, and this is an or because it says greater than or equal to 6 from 0, so that means like 7, 8, 9 from 0, or you would consider this to be like negative 6 is also 6 from 0, so like negative 7, negative 8, negative 9. So we're going to say 7 minus 6x greater than 6, or 7 minus 6x less than negative 6. Notice I switched the sign when I used the negative 6 value there. Let's go ahead and solve this then. I'm going to subtract 7. That's negative 6x greater than negative 1. Divide by negative 6, and when I divide by a negative, the sign flips and I get x less than 1/6. Or, subtract the 7, I get negative 6x less than negative 13. Divide by negative 6, and I get x greater than 13 over 6. So when I draw this on the number line, right, we'd have 1/6 being smaller than 13 over 6. So we have 1/6 and 13 over 6. So we end up with an open dot going this way, open dot going this way. So this means that our interval notation is going to go from negative infinity to 1/6, but not including it, union 13 over 6, comma, infinity. So that's the first way to solve this inequality. The second way to solve the inequality, so way 2, is to take this inequality here, set it equal to 6. So we're going to say absolute value of 7 minus 6x equals 6. And then we're going to solve it for the roots. And when we do that, we say 7 minus 6x equals 6, or 7 minus 6x equal negative 6. We subtract the 7, we get negative 6x equal negative 1, divide by negative 6, and we get x equals 1/6. Or, subtract the 7, we get negative 6x equal negative 13, divide by negative 6, and x equal 13 over 6. Then we draw the number line just like we did right here, and we write 1/6 and 13 over 6. And then we're going to test some points. So I'm going to test 0. I'm going to test 1, because 1's between 1/6 and 13 over 6. And let's just test 10 out here. So I'm going to test some points to see which points will give me a value that are greater than 6 here. So when I put 0 here, essentially what I'm doing is I'm saying absolute value of 7 minus 6 times 0, is this greater than 6? We'll end up with the absolute value of 7 greater than 0. Absolute value of 7 is 7. That's greater than 6. I meant to say greater than 6 earlier. So this area works. Now I do the same thing with the 1. I plug a 1 in here. 6 times 1 will give you, this negative 6 times 1 will give you negative 6. 7 minus 6 is 1. Absolute value of 1 greater than 6? No. This area doesn't work, and you can see that right here in this problem. Plug in the 10. You get negative 60 in there. 7 minus negative 60 is going to be negative 53. You take the absolute value of that, you get 53. That's greater than 6. This area works. So you end up with the exact same solution, right? Negative infinity to 1/6, and then 13 over 6 to infinity. I like way 2 the best because this applies to polynomial inequalities and quadratic inequalities. So this is my favorite way to do this type of problem.